We will have on stage a startup company. It's Envision AI. Envision AI with Thomas Jelonek, the founder of Envision AI.
Well, thank you very much. My name is Thomas. I'm with Envision AI, and I'm excited to sort of demonstrate some of the recent work we've done. We have a new product that we're just releasing called Best Tag, and it's all about maximizing image discovery, especially on Instagram. So we were looking to increase image engagement via discoverability maximization. We actually started off, we were looking at how to provide metrics for image quality. And we thought that we could maximize image engagement by looking at image quality. And what we actually discovered was actually this was not true. Image quality does not map very well to images which are very popular, let's say, on Instagram. And it kind of makes sense because you could have like an amazing painting, for example, and if it's just squirreled away in your closet, nobody will see it and nobody cares. And that's sort of some of the effects that we were seeing. So then the question would be, could we take what images, posts, or people are putting up, map it to some metadata, and then use that metadata to be able to get other people to see those images and discover it? And so that's sort of the core problem. And one thing to realize is that, for example, and this occurs on all kinds of different sort of social platforms, but in, let's say, in hashtags which are used extensively on Instagram, it's not object recognition, right? We're not looking to describe what's in the object or in the image. We're looking to be able to people to find it. In fact, actually describing what's in the image is often a very bad strategy. So here's the data that we actually have. So we have about 30 million images, and we have about 100 million labels, right? So this is not ImageNet, right? And again, on Instagram, people can use up to 30 hashtags for any image. And the other thing, which is, and this is a very noisy, incredibly noisy data set, I'm going to talk a bit about that. But there's also people make up words. And these words often are very, very efficient. For example, and a priori, I don't know what actually the labels should be. For example, just there's a word blonde, which there's about 500,000 images which are labeled blonde, right? I don't know if anybody knows what that means. It's actually blonde plus brown hair. Because the image is so noisy, we cannot look, for example, if we want to build a set of 30 hashtags, we cannot do things like looking at co-occurrence rates in the user data because it's just too noisy. And also, labels are not mutually exclusive, so some label can be very appropriate for all kinds of different types of images. So by noisy labels, I mean stuff like this. So for example, you have a picture of nails, and a person could use 30 hashtags to describe it, but in this case, they only used 5. In the middle one, which looks very similar, they actually use hair hashtags mostly. So they describe long hair, eyebrows, haircut, nothing to do with the image. The third is actually really good hashtags for nails, except it's a cat, right? So that's the sort of data that we actually have to deal with. And so one of the challenges is how are we going to break it down into remove a lot of the really noisy stuff and break it down to stuff which is more manageable. So, and how to map these images to hashtags consistently. So one of the things, what I'd like to just focus on something, we use lots of strategies. We get rid of a lot of the really crappy hashtags, for example, like to like, which sort of pollutes Instagram. But what we did find is that if we actually use millions of images to train a network, the actual results weren't so bad. And so we actually had a hypothesis that we could look at the final layer weight matrix of some of our neural networks, and that could predict co-occurrence of different labels. And labels which we don't know in advance, right? We don't have knowledge of what actually can be out there. And so that we can group hashtags together and cluster them based upon similarity measures. And so let's go back to Brond, as I was talking about before, and we have this sort of cluster. So what you're seeing in the right-hand side is an affinity matrix results of looking at distances from Brond to different types of hashtags. And, this was stuff that was not actually trained into the network, but actually it has real semantic information, like balayage is the technique that one uses to get blonde hair. And then there's, baby lights and blonde balayage and, people, again, making up these different terms. Blonde hair becomes a tag. So what actually this is very useful for us is because we can use this to go through all kinds of areas throughout the whole Instagram space. We're going through different market verticals, makeup and fashion and travel and et cetera. And so it allows us not to have any a priori information about these different areas, and automatically it's going to be able to do this sort of clustering, and then we can train neural networks on these subsets. The other thing, which is also this is very useful for, is that trends occur very rapidly on Instagram. There's new fashions, there's new techniques, new products, and so we actually can use this to see trends happening very, very rapidly. So how do we put this all together? So we actually use sort of a multi-layer approach, like a sort of course define. So we have some deep net classifiers, which will then select from an ensemble of models. And then we have further deep nets, which perform image to hashtag, as I described before, and a set of candidates come out. And then, so for example, you can see one example of what output could look like for this one image, actually. And it's sort of interesting, like it's not necessarily describing exactly what's in there, but it sort of does, and actually some of the things come out quite interesting, like desert dust palette, which is sort of a description of the color shades. And this, one of the things also just to mention, one of the reasons why we decided to look at this is because some of the hashtags have huge amounts of images there. So you can look at, like, for example, pound, I don't know, makeup might have 100 million images. And so you don't want to use that because you get lost in the noise if you use these sort of hashtags. And some of them are very, very specific. So you can make up your own name and there might be just one. And so you can imagine that there's sort of an optimization that can occur in between. And that's sort of what we're trying to do. But because the data set is varying, we actually need another step, which is an adaptive agent, which is able to constantly monitor performance and make adjustments according to whatever the results might be, to look at what sort of engagement is it achieving and then make an adjustment. And just from a sort of technical perspective or implementation, this is all sort of going cloud computing, and what's most interesting is perhaps this adaptive agent actually can be implemented as serverless instances, right? So it can actually monitor customers' accounts, look to see if there's a new post. If there is a new post, find and inject a number of hashtags, and then constantly monitor performance, maybe make adjustments, actually also do experiments, right? Because if you add 30 hashtags at a time, you just sort of see some aggregate result, and you don't know which individual ones are actually doing well. So you can actually use strategies to maybe just for a short time, just try one hashtag and see if that's working. The other thing which also is going on is because there's such a time varying aspect to this, it can depend upon holidays or different days, different things, and also like there's a long-term trend which we're not aware of. So this adaptive element is quite important. And so what is the result? I mean, we don't really care, going back to what those the output here, which is a set of hashtags, is just a means to an end. And the end is actually to try and drive engagement. So this is sort of an A/B test that we were sort of doing, and it's kind of typical for the sort of results that we get, where, in the yellow, you sort of see a typical type result, which is, for this sort of account is reasonable, but, with our system, we're actually able to achieve something like, a 10 order of magnitude improvement, which was surprisingly good for us. And, I started off the discussion saying, we were thinking about looking at image quality and things like that. So you could say, well, maybe, this is from these two images. This test is from the same account. This taken and posted at about the same time, but maybe the two images have a different, one might be better than the other. So actually, here's what the two images were like. So they're distinctive, very, very different, but very similar. And I don't know which one is actually better, but in fact, it sort of demonstrates this idea that how important discoverability might be, in this whole system to actually drive engagement, to drive value of people's image and video content. So, thank you.